So first of all, I want to thank Rudy Kruschke for the invitation to give this lecture. I realise how important it is, and to all of the distinguished guests and to all of the collected stakeholders of Aoife Tullen, it's a real pleasure to be here. So Rudy apologised for the meeting being in German. What I apologise for is my lecture being in English. And yes, because even more so because I have this strange accent because I come from Northern Ireland. And some people think I come from Scotland. It's a very important day for Scotland because they are deciding whether they want to stay or leave the United Kingdom. And my belief is the people from Scotland, Northern Ireland and Wales should be voting whether we keep the English. So Rudy asked me to give a lecture on something that was an important topic. And I couldn't think of anything more important than having a safe and secure food supply system. So in relation to my position at Queen's University, in the 9th year of a project, and the project is to develop a world's leading centre of food security. And where we are now is behind you, you'll see all of the different research themes that we have collected together over a 9-year period. And it is to look at the total system, right from our climate through crop production, raising animals, producing food, and what impact that food has in a positive and negative way on the human population. And as Rudy said, what I'm very pleased is that the centre of the research is science, and what we have built is a fantastic systems biology technology centre. And one of the great challenges about bringing lots of researchers together is actually making them work together. And one of my great projects I now describe as the interactome, how to get all of these different research groups to work together. And I'm trying many different ways how to bring about the cross-disciplinary, multidisciplinary research to tackle some of the major issues. Several years ago, the senior management of the university were trying to decide what the major research themes should be for Queen's University in the 21st century. And I told them food security should be one of them. And thankfully they agreed with me. So we are now embarking on the next stage of our big project. We are building a new state-of-the-art institute right in the main campus of Queen's University. It's a €50 million project, and we're building an institute of 11,000 square metres. And in this institute, we do want to make it the world's leading institute in food security. And the plans are that we will have an academic and a research group of around 250 people working on the one subject. When I try to define what our institute is about, it's about two things. The first is about integrity of food supply systems, and I'm going to talk to you more about that. But the other thing is about having a very competitive food industry. Because in Northern Ireland, agriculture and food production is our biggest industry. It employs 20% of the entire population, and we export 80% of all the food that we produce. And what I say to everybody is that what we need to do is to produce food very competitively, but also with the highest degree of integrity. And a lot of what we are doing is we are developing systems for our own agriculture and food system that we want to export around the world. So in relation to food security, there are many different definitions of food security. But I like this one because it's short and it's simple. It just says that all people should have access to food. The food should be nutritious, safe, and they must be able to afford to pay for it. In relation to food integrity, it's maybe a phrase, terminology that you haven't heard of before. So food integrity is about producing safe food in a sustainable way that is authentic. And it respects not only the farm animals, but all of those people who produce and sell the food. So food integrity in relation to the research we conduct at Queen's University is of very, very high importance. Quite often when I am teaching my undergraduate students, I start off by talking about supply chains, food supply chains. And we start off to say that it starts here with production of crops and it ends here. But actually, that is not a food supply chain. That's a food supply chain. And what I always worry my students, I say, now you've got 5 minutes to memorize that slide. Because it's incredibly complicated and has got more and more complicated over the past 20 years because of the globalization of food. And each time that you see an arrow or an intersection introduces a vulnerability to the food system. It's not a supply chain, it is a supply network, a complicated network. So supply networks have multiple points of vulnerability. And each supply network is completely different. The network for red meat, white meat, eggs, fish, fruit, vegetables, they are all completely different and have different vulnerabilities associated with them. Accidental food contamination can happen by a number of different ways. First of all, it can be the actual processes involved in manufacturing food. How we treat food with heat can produce toxic elements like acrylamide and heterocyclic amines. The packaging materials that we use for food now, based on polymer science, can also introduce contaminants into our food system. And what we don't know is the impact on human health of that contamination. When you ask most people about food safety, they will tell you it is about microbiology. It's problems of living organisms. And indeed, we can have threats from bacteria, from viruses, from parasites. When we get large-scale food contamination from microbiological sources, we know about it very quickly because lots of people get sick very quickly. In the United Kingdom, 3 weeks ago, we had a large outbreak of salmonella. Hundreds of people affected. 3 weeks later, we still don't know the source of the contamination because of complicated food networks. In the United States, an advanced country, they have an estimated 5 million cases of food poisoning now each year. 5 million for the world's most advanced country. And in only 20% of cases, they can identify the cause and where the contamination happened. In relation to chemical contamination, that can happen through man-made compounds, drugs and pesticides, or through naturally occurring compounds, such as mycotoxins and phycotoxins. I thought, Rudy, I had to mention mycotoxins at least 3 times. Okay, so that's 1. Now, the impact of contamination of food with natural and man-made compounds is still not fully understood. So you can look at the epidemiology of contamination of particularly mycotoxins in the developed world, and particularly in sub-Saharan Africa, and you can see an enormous impact. People die in their thousands from exposure. However, what we don't know, what about long-term exposure to small concentrations of multiple risk factors? We don't know that. So a friend of mine who is a very, very good epidemiologist, he thinks that somewhere between 30 and 40% of all cancers are due to that exposure. So we have multiple risks from accidental contamination of supply chains. So one of the things that this lecture got me to think about was we have plenty of problems already. What problems lie for us in the future? And one of those is the complexity of global supply systems. Quite often now, what we eat, where it comes from, we have no idea. And I always use the example of a pizza. So you think, where do pizzas come from? Well, pizzas come from Italy. A pizza is made of about 40 different ingredients. And when I took one pizza with a friend of mine from another university, we were able to source 25 different countries where the ingredients came from. That's one pizza. Another great change in what's happening in global food supply is the emergence of Southeast Asia, India and China. The populations are growing, but the populations are becoming much more affluent. Chinese people want high quality food, and they can afford to buy that food. So it is estimated by the year 2020 in China, the middle class will be the same population as the entire population of the United Kingdom, 60 million people. And what is happening is the dynamics of food supply are changing. Where we in Europe could rely on plenty of foodstuffs, low-cost foodstuffs, coming from South America, coming from Southeast Asia, we cannot in the future, because they will be going to China. Climate change we hear about frequently, but very infrequently about food supplies. So what is happening in relation to climate change is that the threats to agricultural systems, crop systems and animal systems are changing. New types of outbreaks of disease are being monitored regularly now. And I'll give you one specific example of that. One of my great interests is looking at marine toxins. So marine toxins are produced by tiny algae, and what happens is bigger algae eat the little algae, and then what happens is shellfish and fish eat the big algae. So you have a food web, and some of these algae produce very, very harmful toxins, and these toxins can kill people. So there's one particular toxin called ciguatoxin. So just to make sure you can all understand me, I'm going to ask for a show of hands. How many people in this room have ever heard of ciguatoxin? Okay, so at least 10% of people understand my accent. So ciguatoxin is only found in the Caribbean. And in fact, in the Caribbean islands, it's extremely dangerous to eat reef fish. I hope you didn't eat too much during your holiday, Rudy, because those reef fish contain high concentrations of ciguatera. And each year, in the Caribbean islands, many hundreds of people get ill. The algae that produces ciguatoxin is called gambardiscus. And gambardiscus only grows in the Caribbean because it likes nice warm water. Last year, for the first time in history, a report of somebody suffering from cigua poisoning happened in the Canary Islands. So I now know ciguatera and the gambardiscus toxin is moving north. 2 months ago, the second case happened in the Canary Islands. And what we are estimating is by the end of this decade, gambardiscus will reach the Mediterranean. We will have major problems with the fishing industry in the Mediterranean in the future, and that impacts greatly on food security. That's just one small example of how one algae can impact an entire food supply system. And in relation to climate change, we can blame ourselves or we can just blame nature. Is it because we burn a lot of carbon fuels, or is it an event that was just going to happen anyway? What we cannot blame nature on is the amount of contamination that has happened since the Industrial Revolution. Huge areas of land, huge areas of water, fresh water, marine water, are now heavily contaminated. And because of the shortage of land and the need for food, people are starting to grow crops more and more on contaminated land and from polluted marine environments. In fact, I was reading recently that now in Canada, Health Canada, Rudy, you know Health Canada, are warning people about the amount of fish they eat now because of the likely impact of the mercury that's in the fish. Another major issue we have in the future is the emergence of antibiotic resistance. So we all know there's a great challenge now in relation to pathogens, MRSA and so forth, that are impacting on the health and well-being of the human population. What many people don't know is that 50%, half of all the antibiotics produced in the world, go into farm animal production. And those antibiotics are becoming less and less effective. So what farmers are starting to do is use lots of different antibiotics, and that will have a major impact on how humans can deal with infectious disease. So we have a few challenges ahead. Now, in relation to another challenge, I talked about accidental contamination of food, and now we've got to think about deliberate contamination of food. So how does food become deliberately contaminated? So we are now in the era of food terrorism. And for many of us, we don't think about this, but it happens. A couple of months ago, 10,000 people in Japan were poisoned because of huge amounts of pesticides that was appearing in their food. Where did that pesticide came from? It came from one employee in one food company who was very unhappy with his employer, and he emptied 25 kilograms of pesticide into production of bread. And that happens actually quite regularly across the world, disgruntled employees in food factories. And then we have the issue about fraud in food production. So for those of you who don't know about food fraud, it's estimated that about 10% of all the food that we buy has some form of fraud associated with it. And that's much more in the developed world. Estimates put it at least 20%, and in some countries up to 50%. Economically, it costs somewhere in the region of $10 to $15 billion a year. And food fraud can have a huge negative impact on food safety and human nutrition. So if we think about over the last number of years, some of the big scandals that have been associated with food fraud, and probably quite a lot of you will remember melamine. So melamine is a great example of food fraud because melamine is a waste product from the plastic industry, and it was being used in China to add to milk. And it was being added to milk because melamine has a very high nitrogen content. And the quality of milk is based on the amount of protein present. And how do you measure protein? You measure nitrogen. It's estimated that 300,000 babies in China were hospitalized because of melamine, and multiple deaths. Something closer to home in the United Kingdom, about 10 years ago, we found that our food supply system was contaminated with Sudan dyes. Why Sudan dyes? Well, Sudan dyes were being added to chili products. And why chili? Because on the world's trading markets, chili is bought and sold based on the intensity of the red colour. So if you add a red dye to something, it's worth much more money to you. And even closer to home, just 4 or 5 years ago, we found that our animal feed supply system was contaminated with dioxins and PCBs because of fraudulent buying and selling of oils. So we had animal oils being substituted with mineral oils. The cost of 1 gram of dioxin getting into our food supply system was estimated at 400 million euros. Even more recently, 2013, January 2013, the 10th of January 2013, the biggest scandal in the UK in relation to food supply since BSE happened. What was uncovered was that we had horse meat was being used in our food supply system instead of beef. Now, in some parts of the world, perhaps in Austria, that's not such a big deal. In the UK, we don't eat horse meat. But even more importantly, what we found out was that our biggest food producers, our biggest retailers, had fraudulent activity going on in their supply systems, and they did not know about it. The public confidence in food production in the UK reached an all-time low in 2013, and only now is it starting to come back again. I was asked by the UK government to undertake an investigation about how this fraud happened. And it started off as a very simple contract that one of Europe's largest meat companies in Ireland had to supply Europe's second largest retailer, Tesco, in England with beef. Very simple contract. However, what the company in Ireland did was, because the price of Irish beef was very high at that time, they decided that they would buy beef from somewhere else. And they bought beef from Poland. So they broke the terms of their contract, but what they thought was, does it really matter? And what they did was, whenever they thought they were buying beef, there was a huge amount of fraud went on in Poland, and some of the beef was substituted for horse meat and ended up in the Irish supplier who supplied Tesco's. The estimate is that that single problem with the supply chain cost Tesco £300 million sterling. Another fraud that went on was with Findus. So we now call it the famous Findus lasagna. Findus, again, one of Europe's largest food producing companies, it was found in their lasagna that it was 100% horse meat, 0% beef. There was no beef there at all. And when I tried to find out how that had happened, what I found was this incredible web of fraud was going on. Multiple people involved, and it was, I describe it as an organised criminal network. You may not be worried about getting horse meat in your beef supply chain. One thing to remember is that's just one example of how fraud can happen in a multi-billion euro industry. And there's many different types of fraud. Substitution fraud is what I explained about substituting one product for another. Addition fraud is where you add something to a food to give it a higher value, such as melamine or Sudan. You can also have geographic fraud. You think you're buying a food product from one country and you're not, it's come from somewhere else. And there's a huge amount of fraud about false claims. So on your package of food, it says it's organic, it says it's for fair trade, and it's not. So here's another interesting statistic. Over the last decade, the amount of organic food produced in the world has doubled. The amount of organic food sold in the world has trebled. Think about the mathematics. And I always like to talk about fraud in fish because it's wonderful, because it encompasses every possible type of fraud. You might be buying the wrong species. You might be adding fraud with chemicals added to it to swell it up. You might be buying fish that you think comes from one part of the world and comes from another. Fraud in fish is magnificent. But there's a very serious side to fraud. And I show this example because it's something that I picked up last year, that food that was not fit for human consumption in Europe was getting sent to Africa to eat. And what they were doing, the fraudsters, with this meat that they were buying for next to nothing, they were spraying it with formaldehyde. Yeah. To preserve the food. And formaldehyde treatment of food in southern Africa and Southeast Asia is very common. So, lots of problems naturally occurring, some of it due to fraudulent activity. So I just want to finish off with, there is a major role for science in protecting the integrity of our supply chains. And I just want to give you some examples, and these are examples of things that my institute are working on. So we call them track and trace technologies. So we're now looking at how can you track food products through very complex supply chains? And we're looking at innovative IT technologies to do that. We're also thinking about the scientific possibility and the ethics of thinking about starting to add tracer molecules to food to see if we can track those through supply chains. And there's a lot of ethics about should you add something to food just to look at its traceability. Second and last question for everybody in this room. How many of you have eaten Ben and Jerry's ice cream? Okay. All of you have eaten Ben and Jerry's ice cream, you have eaten a tracer molecule. There's so much fraud in ice cream they add, and it's just a vitamin to it, a vitamin that you would not find in ice cream, to find out if there's fraud there. Another major role for science is in trying to remediate land and water that has been contaminated. And in my institute, we have very large projects now going in China to look to see how they can remediate some of their land. They have massive problems. Also in relation to their water supply, very, very heavily contaminated water supply, which promotes the growth of organisms which produce toxic substances. And the third role that my institute is heavily involved in is analysis, because we're a group of analytical chemists. And we talk about targeted and untargeted analysis. We're also in the middle of what I describe as a sensors revolution. So we're back to my very simple supply chain. And through the use of sensor technology, using wireless networks, we can put sensors in crops, and we can now sense when they are subject to an attack by pathogens. We can now sense when you get pathogens, particularly fungi, that will produce toxic substances. And then what that does is that can guide you to whenever you treat your crops with pesticides, with herbicides, or whether you harvest early. At the farm level, we are now developing sensor technologies that can detect contamination of the animal feed materials. We can detect the contamination of materials like eggs and milk. The food processing industry, where many of the problems happen, sensor technologies based on things like Raman and near-infrared can detect abnormalities in their products. And probably the most unusual type of sensor technology we are working with is the smartphone. Yeah, so we all have a phone. So we are now working with one of the world's leading multinational companies to put sensors onto the phone that you can put onto your food, and you can detect contamination. We're starting off with allergens, actually. And the advances in analytical science are incredibly important. So we're now at a point where we can detect many hundreds of different contaminants, natural and man-made, through the use of advanced mass spectrometry. And one of the pioneers of this advancement is Rudy Kruschka and his group here. And I do believe that they have become the world's leading authority in this area, and I congratulate you. And in relation to mass spectrometry, it's getting smaller, it's getting less expensive, and the idea now of producing portable mass spectrometers is becoming a reality. And we're now into the era where we can think about untargeted analysis of food. And what that means is you can start to produce a molecular fingerprint of any type of food. And what you can do when you have that fingerprint, if you test your food and you get an abnormal fingerprint, you know there's a problem. And in my institute now, here's a fingerprint of, here is the uncontaminated, and here's food stuff. that we contaminated with 3 different drugs. Not only were we able to detect the contamination, but based on the fingerprint, we could identify it. So I just want to finish now by 3 statements. First of all, I hope I haven't depressed you too much. So, we have an enormous number of problems currently, and even more in the future, in dealing with the integrity of our food supply systems. But advances in science will play a major role in producing strategies to mitigate those risks, so that what we eat is both safe and authentic. My final statement is, I want to wish the IFA a happy 20th birthday. I do believe it is a fantastic institute, and over the next 20 years will play a major role in food integrity. And with that, I'll say thank you very much for your attention.